With the impact COVID-19 has had on education, utilizing different methods of virtual learning has become a vital resource in replicating the same level of engagement experienced through in-person lectures. The College of Dentistry at the University of Illinois in Chicago is working towards the implementation of VR learning into standard lesson plans for first-year dental students. Continuing development from the previous year's efforts within the same application, our team expanded the program's features further by incorporating additional features available to the professor and students that promote student engagement. The student begins the simulation by choosing their avatar and entering the lecture room. Our team expanded off of the previous year's project and redesigned the layout to promote better flow through the space for VR users. Additional objects in the exam room that are seen to improve student immersion are the desking system and seating arrangement. The wristwatch user interface provides access to two features, the whiteboard and PDF file viewer. By facing their palm upwards, a user gains the ability to view this UI, which provides the controls for these two features. There is also a locking feature that can lock both the whiteboard and PDF in place so the user can access both with ease. The main button expands the interface's options, avoiding screen clutter if the user is simply moving their wrist. Upon expansion, the icons display or hide their corresponding features, ensuring correct orientation facing the player based on the head-mounted display's direction. Interaction with the wrist UI occurs through a finger tap, such as a press of a phone screen. But virtual reality currently lacks the feeling of pressing a physical screen. Haptic feedback in the form of light vibrations fills this void. Additionally, each icon acts as a feature toggle, meaning they change coloration depending on its current status. In a lecture room environment, a place for the professor to present slide presentations sits in the front of the room. The controllers are located at various points in the room, such as both desk and at the back of the room. The primary function implemented was the ability to host a multi-user application in virtual reality. Merging the work from the previous year's progress on the application, we further developed features that allowed users to engage different learning tools such as slide presentations, whiteboards, PDFs, and rooms that offer a place for users to take assessment tests. Expanding on this work's multiplayer functionality, the team has built a collaborative experience for professors and students in an updated virtual lecture room and exam room. For multi-user implementation, the team integrated Photon Unity networking too, remote procedure calls that send local data from one client to all connected users. This ensures the synchronization of objects such as surgical tools and the patient's mouth, along with displays like the slideshow presentation and whiteboard in either multi-user room. Utilizing an existing exam room from the previous project, our team transformed it to serve as a space for student users to take exams while maintaining immersion in the VR world. The student assessment room offers the user a place to practice dental procedures on a fake patient. When the player picks up the tool and begins operating on the patient, the controllers vibrate to create the sensation that the player is actually holding the drill.